Thank you very much, Jenny. Good morning, everyone. Good afternoon, depending where you're listening to this talk. Over the next 20 minutes or so, I'll go through some key elements of the MSc Applied Data Science in Engineering. I do have a set of slides which are wrapped around the idea of the story so far, the current mode of delivery, and probably some examples of the student project done in collaboration with industry. So I'll start with probably a set of bullet points, which, as I said, capture the story so far. In 2019, I was tasked to create a new MSc course at Glasgow Caledonian University around the topic of predictive maintenance theme, and I push back mainly because it is a bit too narrow and is just one way to exploit data coming from asset systems and processes. So in other words, we try to articulate the rationale for an MSc course which involves the use of data and data science for engineering applications. And what we did throughout 2019 and probably the second part of 2020, with a brief stop when we tried to readjust during the pandemic, we try to capture the industry requirements, but also not industry requirements, but also requirements articulated by various Scottish development agencies. And I have a slide on that, and I'll come back in a second. What we try to understand is what graduates from the engineering space need to, what sort of skill sets do they need to have in order to tackle jobs and to be able to perform well in modern jobs in engineering environment, which involve a lot more digital analysis and data and data science. What we realized following this requirements capture is the fact that we need a departmental delivery for this course. So you'll be seeing the departments which are contributing to the delivery of the course and the type of skill sets that the graduates and the applicants through this course will tap into. There is an expertise in a single department out there at any single university in the world which can deliver a course like that. So we stretched from computing, mechanical engineering, electrical, network and cybersecurity, but also applied data sciences, where I sit together with a good number of other colleagues. In 2021, we put together the curriculum. So we identified the 8 modules, taught modules that have to be delivered in order to deliver such set of digital engineering skills. And in 2022, in September, we welcomed the very first cohort on campus. To this day, that was a fantastic, I have very good memories of that first cohort. Um, a bunch of extremely keen international students who are doing well right now, and we have some of them regular speakers to talk to the current cohort of MSc students on applied data science and engineering to help them understand how to navigate the job market post graduation from this course. In 2024, in November, we had a successful accreditation event, and I'm happy to report now that the course is accredited by the Institute of Engineering and Technology and the Institute of Measurement and Control. So that was a joint approval event, accreditation event from these two engineering bodies. If you don't see their logos on the website at this point, is that the decision is yet to be processed by both parties before we get the official letters, which will allow us to put the or enable us to put their logos on the website of the program. But this will happen in the next couple of months. It's just paperwork. Let's call it this way. If somebody asked me to use a single slide to describe what this program is, this is the go-to slide. And this sort of captures the predictive maintenance and the transition from predictive maintenance to the overview of digital engineering, and probably alludes to the data in an engineering context these days. You have on the top right corner, a good number of complex systems, examples from aircraft, wind turbines, submarines, trains, but energy systems as well, processes in the automotive, healthcare, um, transportation, and so on. Um, Modern systems are embedded with sensors, and they which are streaming data. That data is acquired, transferred, analyzed locally or remotely, and from that point is presented for different tiers of hierarchy, either to the operational personnel, but also to the maintenance and logistics teams behind the scenes to keep the show running. A good amount of know-how and skills and gaps we identified as being the design, engineering, and manufacturing space. So some of our modules are tapping into that area on how you instrument systems to have the right data in place. A good number of industry sector already have the sensors on specific systems, and you have to work with those with the data coming from those sensors. For other industry sectors, are barely adopting this concept of data science, digital twins. They realize that it's better to go back to the drawing board, to the design drawing board, to understand what's the optimum number of sensors, the minimum number of sensors, which can give you the right data to take the right decision at a later point in time. Moving on, that's a slide that I saw for the very first time in 2019, and this is presenting the bridge between Industry 3.0 and Industry 4.0, and that's where majority of the industrial players are at the moment. Probably at the inside levels where you have some visibility and you can understand what is happening. So you have the ability to see the condition or the performance of specific assets to better understand why something is happening. So that's the transparency level. And I know there are some key pioneers in the area in industry who are already moving into predictability. They understand what will happen if you still run an asset with a specific load under specific operating conditions. So you are starting to be prepared. Moving on into the autonomous reaction actions which are taking place if something is detected. So you're moving into the adaptability layers at the top tier level on the right hand side. I know there are parts of the world where academics and industry are already talking about industry 5.0. Let's not go there. Let's try to prepare graduates, and that's our aim and objective to um, equip graduates from this course with the right set of skills to tackle challenges in the industry 4.0, which I think poses enough challenges, but also opportunities for the engineers these days. Um, I don't have to tell you that data is becoming heavily exploited, available, and then has the possibility to be exploited in almost any industry sector, from transportation, constructions, and building, energy sector, health. Formula One was doing it for a year in order to take real-time decision on how to manage a specific race with a goal to win that race. Agriculture is offering big challenges, but also big pushes in order to have the right equipment ready and fully operational on the right day when a harvest should take place. If you do it a couple of days later, you might be losing a good percentage of that harvest, which for large farms and large operators, this is transforming into large losses. For every single example on this slide, some of my colleagues have case studies that we discuss in the class in order to provide a right spectrum and the degree of detail for the class to understand the concepts used by different parties, but also the opportunities and challenges in using data coming from sensors all the way to the decision making, whether or not you send a tractor or a specific tractor on a specific day on a specific farm to do a specific job. Just to give an example from the agricultural space. In terms of requirements for digital engineering, I said earlier on that we had discussions on a one-to-one with a variety of industrial partners who are supporting, who are sitting in the industrial advisory board for undergraduate, but also specifically postgraduate studies at GCU. So you see them on the left-hand side of the slide. But we also talk to people from the Scottish Manufacturing Advisory Service, from Centre of Engineering and Education Development, Scottish Enterprise, Scottish Engineering, Zero Waste Scotland, and National Manufacturing Institute Scotland. I'm sure every single country has the equivalent of these organizations, who are the middlemen between the Scottish or the local government, but also the industrial players, to understand what needs exist in terms of further qualification and studies for people from industry. So as I said, it was a course developed for with industry for industry, and probably the high rate of um, jobs that our students are quickly tapping on. It's a proof of that. To summarize what every single party told us they need in terms of skills, probably there are four main streams. One, they need graduates who can install sensors on systems, who understand the measurement and the principles of a measurement. They want graduates who can record data and store that data. They want graduates who can analyze that data and use data science and coding skills in order to extract the right insights for the right application for the right asset in the right operating conditions. But also graduates who can visualize data and create simple dashboards, graphs, all the way to very complex dashboards, which are have different tiers of hierarchy to provide the right level of information to the right people. A shop floor technician might need some specific parameters to be displayed to him on a screen on a mobile device, while the maintenance manager of different manufacturing sites or operating assets, large fleet of assets scattered around the world might need some fleet availability graphs to give them a very quick insight on how his fleet is performing. So again, the sequence: sense, acquire, transfer, analyze, act, present, and actually act. And we do that through a variety of modules that we ended up teaching as a result of this requirements prioritization that we carried out with different industrial players, but also those governmental agencies. So in terms of modules, um, there are four taught modules delivered in trimester A, and you have them at the top of this table: software development for data science, system health management, data capture, IoT frameworks informatics. For each of these modules, you should have a link on the website taking you to the module descriptor to see exactly the concept, theme, and topics that you'll be each of the modules will be covering. And then moving on into the trimester B, students will be studying predictive maintenance, data visualization, digital twins, and professional practice. After the completion of these two taught trimesters, the students have the possibility to embark into a project module. So that's done over the duration of a full trimester. It can run in trimester A, B, or C, depending when you start this course. If you start in September or in January, and if you progress at the right time through this module. You see on the right-hand side, on the right-hand side column, the departments where the members of staff of the different module teams sit. So they do have an association with the computing department, with applied science, with the electrical and electronic engineering, cybersecurity and networks, mechanical engineering. Context of digital twins. That's a module that I personally deliver together with a professor, a colleague of mine from the mechanical engineering. So we realized fairly early on that there isn't a single department within the university who can deliver such a course. Some of the two or three modules that they were already on the curriculum for other courses, but some of them are completely brand new, like the digital twins, IoT framework, informatics. Um, and predictive maintenance. So they were designed and shaped for this specific program 3 years ago. So in the case of these particular three modules, this is the third iteration. We're improving things. We're enhancing the material year on year, just to provide a fantastic experience to our class. In terms of assessment, you do have a mix of written courseworks, oral presentations. There is an element of group work and the group oral presentation on one of them. There are two main exams, and if the students progress well, they will be moving on into the projects. We're striving to do the majority of the projects in collaboration with an industrial partner, and the project stress is a good part of the concept learning in the taught modules above. Some of them will have a more flavor of a digital twin concept introduced during that module. Some of them will be focusing more on software development for data science, but it's always a matter of finding the right candidate with the right set of skills, and to match them with an industrial challenge offered by some of the companies that we are having ongoing research, but also ongoing discussions on any of the topics in this space. I do think I have an example on such a project done by one of the students from the very first cohort. But before I do that, I'll highlight some of the experimental facilities that we have at GCU, but also I'll start with the digital twins capabilities periodic table. This is something that the Digital Twin Consortium put forward, and we try to align the delivery of this course and especially MSc projects on the applied data science in engineering along these six streams. One covering data services, so data manipulation, cleaning, storage, and modeling derived from data. One is integration of operational technologies with IT technologies. A big layer on intelligence, so that's the machine learning, AI, digital twins, business rules, and a good number of other topics. User experience, that being the visualization part. So those are type of projects where customers are asking for enhanced dashboards, or are tapping into the expertise of our students to help their engineering team to develop better graphs and better plots, and different ways to visualize data to tell a better story from the data that they already have it, or the data that they realize that they need to record in order to deliver that to user enhanced user experience. Something that we don't tap in, and that's the nature of things, how we manage these solutions in the long run, but how we ensure the trustworthiness. But this doesn't mean that the students aren't aware of this concept, that every single bit of software, hardware, or a combination of software, hardware that is enhancing the availability of a given system, asset, and process is not doesn't need to align with the company's management policies, but also cybersecurity standards that they need to adhere. We do have experimental facilities, some of them full size, as you can see. So we looked at the development of AR solutions, augmented reality solutions to enhance the engineering environment and scope of work. Data presentation. We do have experimental facilities that can generate data. So that's one example that of a system for which the current cohort is developing a digital twin. These such systems are connected to real equipment like PLCs and networking equipment. They generate real data. They run in healthy but also faulty conditions. We tap into with our postgraduate research into multi-component degradation scenarios. Some of these MSc students are working on specific small work packages as part of their MSc project, together with PhD students that we are gravitated um, on topics around the theme of the project. So a fantastic learning experience to learn from their peers, students who have been um, in the class a couple of years ago, and now they decided to do a postgraduate research um, experience via PhD project. We're using real equipment and real IoT framework informatics, like the one from PTC ThingsWorks, and you can see here how things are starting to come together by building digital twins from a specific asset. And the two screens you have on the top right corner are the two screens I have at home. I can visualize the system that exists in Glasgow from 100 miles away. I can see data, but also can tap into the augmented reality experience to visualize, instruct, and interact with a specific asset, which, as I said, is placed remotely. I'll wrap things up with an example of an industrial-led MSc project. So here's a fine example where a graduate with who came to do this course from with a computer science background, first degree, an international student, was attached to a project supported by a company here based in Glasgow, looking at blowers, so compressor used in wastewater treatment plants, and the equipment is equipped with multiple sensors, while is already generating data, and the student had to work on to enhance the statistical process control chart that the company already had. Moving on into and developing an exponentially weighted moving average SPC, which is taking into account different operating regimes. To me, that was a success story coming especially from a guy, as I said, with a top class computer science degree who could not get his head around in the first 2 weeks of the course why he's talking about pumps, valves, equipment, failure modes, reliability, maintenance, because it was completely different from what he studied during the undergraduate degree. His programming skills enable him to fully capture and go through these taught modules. And because he was such an open minded individual, um, he was, after the 2 trimester, he fully understood the story of this program. He developed the right skills and he was selected by this equipment manufacturer in Glasgow to work with their data analytics team, and that's what was the outcome of his solution, which was grabbed by the data analysts and now is running on their own industrial Internet of Things platform for that specific set of customers that the data came from. Instead of skill set paradigm, ask him to quickly wrap the type of skills that he developed during the course. So you have the skill sets on the left hand side, from domain knowledge, data handling, programming skills, which he sort of had before joining the course. But how he used those skills in order to work on compressors used in wastewater treatment plants, that his value added, and probably the the bit of the story that we help them as part of this program. So on the right hand side, he identified the relevant applied data science and engineering modules that help him to solve some domain knowledge elements, some data handling challenges, the programming element of the project, but also strategy in order to come up with the best strategy to handle a given problem, which involves data. Um, in terms of the overall aim and objective, and this is where I will wrap things up, this MSc Data Science in Engineering delivered at GCU aims to contextualize data, data science, data engineering to equip a bunch of mechanical, electrical, control and instrumentation engineers with the right skills to enable them, first of all, the implementation of sensors, data gathering, and the use of data for provision of through life engineering intelligence support solutions. At the same time, and the example that I've just given earlier on, um, we realized that the program is also aimed at data analysts, computer scientists, at least the ones who want to make the transition into the engineering world, to understand data in the context of systems, and more importantly, systems of systems, to deliver the right solutions for the right customers. So with this in mind, that was a brief overview of the MSc Applied Data Science in Engineering. I'll leave the last slide with the overall aim and objective, and if there are any questions, I'm happy to address them. Thank you very much.
Thank you very much for that. I hope everyone found it very interesting and helpful to hear from our speaker today. We don't have any unanswered questions in the chat panel, so I'd just like to thank you for attending and for giving this presentation. I hope it's been useful for everyone. If anyone has questions after this session, do feel free to email those in to us and we'll pick those up.
I think there is a question from
Oh,
Neil, from pharma manufacturing domain. Um, we don't have from pharma. We have two partners that we are currently talking to better understand how to start some collaborative research projects. which is probably the very first steps to enable the development of some case studies. But we do have some case studies from bottling plants of spirits industry sector. Um, we do have a couple of manufacturers on in the Glasgow area, and they are looking at equipment which was designed to support one shift per day in terms of bottling. And suddenly, the demand, with the increase in demand, they are moving into two or three shifts per day. So a lot of that equipment wasn't designed to support such stress. So they are looking into condition monitoring of such bottling plants, which in turn will reduce the downtime and unscheduled maintenance. Everybody is aware that things degrade, but you need to manage the degradation in such a way that you run the right maintenance actions at the right time when you have some gaps in productions, or when you slow down the production at specific times of the year. I'm not sure if Neil this helped in any way. But I do have colleagues in computing who work with data in healthcare applications. So wearable devices being one that comes to mind. If you contact me offline, happy to put you in contact with them. Since we still have a couple of minutes, and if you Neil are still on the line, is it the instrumentation part? Is the data analytics in these manufacturing processes that you're after, or trying to narrow down the question? I'm sitting with the instrumentation group, so happy to follow up with you if you get in touch on how we can help. So we look at we have tools which are looking at maintenance aware design. A lot of people are trying to deploy sensors and without necessarily taking the design aspect into the um, to consideration. And sometimes that's how you have to work. You have a legacy platform that you try to instrument, but you also have for new sites and new manufacturing lines the opportunity to go back to the drawing board to understand what it fails, how it fails, and instrument things in the most optimum way. So I can send you a couple of details on the tool set that we're using to tap into the maintenance aware design philosophies. And they were trialed by the aerospace industry sector. NASA in using them, and they are generic enough to model every single type of system out there with some caveats and customizations, obviously. One thing which might be worth mentioning right at the end, you can do this course full-time mode while being on campus, but we are already having a couple of MSc students doing it in distance learning mode. So every single trimester they take over two modules and they get support online and the material being shared and discussed via the GCU Blackboard.
Okay, I think that's all the questions from our audience. I'd just like to thank everybody for your attendance today, and I think we can wrap it up here.
Thank you very much.
Thank you.